Welcome to the Explainer. Today we're actually going to look at something you probably interact with all the time, but never really see. We're diving into the hidden, super intelligent tech that keeps our global rail systems running smoothly, and most importantly, safely. Specifically, we're demystifying the Siemens ClearGuard ACM 200 system. It's a really fascinating look at the digital asset management happening right behind the scenes of our daily commutes. To really appreciate this, we got to start with a massive, high-stakes question. Just picture a modern, high-speed train hurtling down the tracks at up to 400 kilometers per hour. That's like 250 miles an hour. At those blistering speeds, the stopping distance is absolutely massive, and there is literally zero margin for error. So how do rail systems guarantee that a train moving that fast has a perfectly clear path ahead? Well, it takes absolute precision and flawless communication, all happening in fractions of a second. Here's our roadmap for breaking down this engineering marvel today, from the macro network level right down to the micro hardware level. Number 1, the track vacancy detection problem. 2, counting axles with ClearGuard. 3, smart modular hardware components. 4, web diagnostics and easy maintenance. And finally, 5, safe, cost-effective rail automation. All right, let's jump right into part 1, the track vacancy detection problem. The fundamental challenge every single rail operator faces is knowing exactly where their trains are at any given millisecond. That is absolutely crucial for preventing catastrophic collisions and just keeping things running efficiently. Now, you'll hear this bulky industry term, track vacancy detection. Honestly, don't let the jargon intimidate you. It's simply the concept of knowing a track is completely empty before sending another train down it. It is the absolute baseline for all rail automation because, well, you can't automate what you can't see. And here's what that looks like on a macro level. You've got multiple track sections and switches, and they have to constantly communicate their status, whether they're clear or occupied, back to a central interlocking system. As a train moves across the network, it occupies one section and clears the previous one. It's like a giant puzzle, and this entire interconnected web relies on flawless data to keep traffic flowing safely. Moving right along to Section 2, counting axles with ClearGuard. So how does that macro concept actually work mechanically? Well, think of this three-step process kind of like an incredibly meticulous bouncer at a venue. Step 1, specific wheel detection pulses are transmitted from trackside sensors the moment a train wheel rolls over them. Step 2, the system's brain compares the exact number of axles entering a section with the exact number leaving it. Step 3, if the numbers match, say 50 axles went in and 50 came out, the system knows for sure the section is empty. It then safely sends a clear status to the interlocking building. If the numbers don't match, the section stays occupied. It's just brilliant fail-safe logic. Let's take a look at Section 3, smart modular hardware components. To really grasp this, we need to look at the physical equipment actually doing the heavy lifting. There's a very clear visual separation going on. On the outside, you have the ridiculously rugged ClearGuard ZP D43 wheel detector. It's bolted right to the rails, braving the elements, physically detecting the passing wheels. Then, on the inside, you have the highly compact, smart ACM 200 computer modules safely housed indoors. The outdoor sensors grab the raw data, and the indoor modules are the brains crunching the numbers and talking to the broader network. Now, I'm not going to read every single number to you here, but just take a second to appreciate the extreme engineering tolerances we're dealing with. This system survives brutal temperatures from -40 all the way to +70 degrees Celsius. It effortlessly handles trains zipping by at 400 kilometers per hour. And look at that counting capacity, 32,767 axles per section. If you're a bit of a tech nerd, you might instantly recognize that exact number as the limit of a 16-bit integer. Kind of a neat little hint at the digital brain inside. And it does all of this while drawing just 5 watts of power for the trackside detector. And this right here is a massive operational leap for the rail industry. Back in the day, fixing a broken component meant completely shutting down power and causing huge delays. But these ACM 200 modules can actually be hot swapped. That means engineers can replace them while they're energized without interrupting a thing. Even better, the entire configuration of the unit is stored on a tiny little ID plug. A technician literally just pops the plug out of the old unit, clicks it into the new one, and boom, the system is instantly back online. It is incredibly efficient. Let's head into Section 4, web diagnostics and easy maintenance. Moving past the physical hardware, how do engineers actually maintain this thing in the modern era?
Well, because these modules operate on a standard Ethernet bus, they have their own IP addresses. That means an engineer can literally just stand by the tracks, hook up a standard laptop with an Ethernet cord, and use a basic HTML web browser for instant on-site status checks. Absolutely no clunky proprietary software needed.
So what does that interface actually give them? Well, because each module has its own IP address, operators get incredible system transparency. They use standard HTML to configure things, check logs, and run diagnostics. But the real game changer is remote diagnostics. You don't even have to be trackside. You can securely access this via the internet or an internet from anywhere at any time. You get instant graphical readouts on track occupancy, total axle counts, and even the real-time health of the sensors. Ultimately, all of this translates to drastically reduced maintenance downtime.
And finally, Section 5, safe, cost-effective rail automation. Zooming back out to the big picture of global mobility, the contrast is pretty stark. Traditional systems relied on all these complex variations of hardware, they needed extensive manual resets, and suffered from super high lifecycle costs. ClearGuard completely flips that script by replacing all those varied parts with one standard modular unit, connecting it via standard Ethernet, and using that genius little ID plug. Siemens has drastically lowered both the initial installation costs and the long-term maintenance costs. It is a total win-win for efficiency. Of course, we absolutely cannot talk about rail infrastructure without talking about safety. The ClearGuard system achieves SIL 4. That stands for Safety Integrity Level 4, which is literally the highest possible safety rating defined by European standards. It achieves this using a fail-safe 2 out of 2 microcomputer configuration known as the Siemens principle. Basically, you have two completely independent computers constantly checking each other's work to guarantee absolute safety in the interlocking system.
So we've covered everything from macro network challenges to track-side axle counting all the way down to IP addresses and SIL 4 safety ratings. I want to leave you with this. The next time you're riding a train just staring out the window as the world blurs by, will you notice the invisible digital safety nets protecting your commute? It's really easy to take for granted, but hopefully you now have a profound appreciation for the unseen layer of intelligent engineering keeping your daily journeys safe, fast, and remarkably seamless. Thanks for joining me on this explainer, and definitely keep your eyes open for the hidden technology all around you.